is called n factorial denoted by this symbol or this symbol. N factorial is equal to 1 into 2 into 3 up to n minus 1 into n. So 2 factorial will be 1 into 2 equals to 2. 3 factorial equals to 1 into 2 into 3, which is equal to 6. 4 factorial is equal to 1 into 2 into 3 into 4 is equal to 24. 5 factorial is equal to 1 into 2 into 3 into 4 into 5 is equal to 120. And then a note point, factorial of negative numbers and fractions doesn't exist. Factorial of negative numbers and fractions doesn't exist. Expressed in factorial notation, three into 4 into 5 into 6 into 7. If you want to express in factorial notation, so you have to multiply 1 into 2, 1 into 2 into 3 into 4, 5 into 6 into 7, divided by 1 into 2. This is equal to 7 factorial divided by 2 factorial. Question number 2, prove that one into 3 into 5 up to 2n minus 1 equals to फास्टा बुझिपारलनि अच्छा से कही 3 into 4 into 5 into 6 into 7 या फैक्टोरियल नोटेशन को कन्वर्ट करिया फैक्टोरियल नोटेशन कंटिन्यूड प्रोडक्ट फ्रॉम 1 टू ताले एठी को 1 तर कंटिन्यूड प्रोडक्ट नाही 3 4 5 6 7 अछि 1 टू मल्टीप्लाई कले 1 टू डिवाइड कले ताले 1 तर 7 कंटिन्यूड प्रोडक्ट एकला 7 फैक्टोरियल डिवाइडेड बाय 1 into 2 is equal to 2 factorial. ବୁଝିହେଲା ପୂଜା? Prove that 1 into 3 into 5 up to 2n minus 1 is equal to 2n factorial divided by 2 to the power n into n factorial. କରିପାରୁଛ? 1 into 3 into 5 into 7 into 2n minus 1. We have to convert it into factorial notation. From 1 to 2n, all the odd numbers are present. Okay. We should insert the even numbers. So this is equal to 1 into 2 into 3 into 4, 5 into 6, up to 2n minus 1 into 2n divided by 2 into 4 into 6 up to 2n. Clear? Now the numerator is the continuous product from 1 to 2n. It will be 2n factorial divided by 2 into 4 into 6 up to 2n. Now we can take 2 as common from each of the So we can take 2 as common from each of the term in the denominator. This should be 2 to the power n into 1 into 2 into 3 up to n. This is equal to 2n factorial divided by 2 to the power n into n factorial. Is it clear? Did you understand, guys? Hello. Next question. Prove that okay. The last question was 1 into 3 into 5 into 7 up to 2n minus 1. आपको हमें प्रूव करिए 2n फैक्टोरियल डिवाइडेड बाय 2 to the power n into n फैक्टोरियल. तो 1 ଠାରୁ 2n ପର୍ଯ୍ୟନ୍ତ ସବୁ ଅଡ୍ ନମ୍ବର ଗୁଡ଼ା ଆଭେଲେବୁଲ ଅଛି, ଇଭିନ୍ ନମ୍ବର ନାହିଁ. ତେଣୁ ଇଭିନ୍ ନମ୍ବର ଗୁଡ଼ା ମଲ୍ଟିପ୍ଲାଏ କରିବା, ଡିଭାଇଡ୍ କରିବା. So this will be 1 into 2 into 3 into 4 2n minus 1 into 2n divided by 2 4 6 ନଥିଲା, ଆମେ ତାକୁ ଇଣ୍ଟ୍ରୋଡ୍ୟୁସ୍ କଲେ, ତେଣୁ ସେ 2 4 6 up to 2n ଡିଭାଇଡ୍ କରିବା. ବର୍ତ୍ତମାନ ନ୍ୟୁମରେଟର ହେଇଗଲା continued product from 1 to 2n. It will be 2n factorial divided by 2 4 6 up to 2n. 2 को हम लिखिପାରିବା 1 into 2, 4 को लिखिପାରିବା 2 into 2, 6 लिखिପାରିବା 2 into 3, and 2n can be written as 2 into n. तो ସବୁଥିରୁ ଯଦି ଗୋଟେ ଗୋଟେ 2 କମନ୍ ନେଇଯିବା, 2 into 2 into 2 into 2 n times 2 to the power n, this is equal to 2n factorial divided by 2 to the power n into 1 2 3 up to n. This is equal to 2n factorial divided by 2 to the power n into n factorial. ବୁଝିହେଲା ଏବେ? ବୁଝା? ପ୍ରତିଶ୍ରୁତି ବୁଝିହେଲା? ହ୍ୟାଲୋ. ଓକେ. नेक्स्ट क्वेश्चन लिख। 2 ର ପାୱାର 3 ନେଲେ 8 ଆସିବ, 2 ନେଲେ 4 ଆସିବ। ନେକ୍ସଟ କ୍वेଶ୍ଚନ ଲେଖ। 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus up to n into n factorial is equal to n plus 1 factorial minus 1. Prove that 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus up to n into n factorial is equal to n plus 1 factorial minus 1. Prove करिबा। 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus up to n into n factorial is equal to summation notation लिखिबा। This is equal to sigma r is equal to 1 to n r into r factorial. If you take r is equal to 1, then it will give you the first term, that is 1 into 1 factorial. For r is equal to 2, it will be 2 into 2 factorial. For r is equal to 3, 3 into 3 factorial. For r is equal to n, it will be n into n factorial. This is equal to sigma r is equal to 1 to n r into r factorial. This is equal to sigma r is equal to 1 to n r factorial into r this is equal to sigma r is equal to 1 to n r factorial into r plus 1 minus 1. R factorial into r plus 1 minus r factorial. This is equal to sigma r is equal to 1 to n r plus 1 factorial minus r factorial. This is equal to, if you take r is equal to 2, it will be 2 factorial minus 1 factorial. For r is equal to 2, it will be 3 factorial minus 2 factorial. For r is equal to 3, it will be 4 factorial minus 3 factorial. For r is equal to n, it will be n plus 1 factorial minus n factorial. Plus 2 factorial minus 2 factorial cancels. So this is equal to n plus 1 factorial minus 1 factorial. This is equal to n plus 1 factorial minus 1. Is it clear? Hello. Sigma r is equal to 1 to n. R factorial into r. This is equal to sigma r is equal to 1 to n. R factorial into r plus 1 minus 1. This is equal to sigma r is equal to 1 to n. R plus 1 factorial minus r factorial. ଏବେ r ର ଗୋଟେ ଗୋଟେ ଭ୍ୟାଲୁ r is equal to 1 put କଲେ କେତେ ଆସିବ? 2 factorial minus 1 factorial. For r is equal to 2, 3 factorial minus 2 factorial. For r is equal to 3, 4 factorial minus 3 factorial. For r is equal to n, it will be n plus 1 factorial minus n factorial. सब जगह add कले 2 factorial 2 factorial cancels, 3 factorial 3 factorial cancels. इन सब जगह cancel क्या रहइबो केते? n plus 1 factorial minus 1 factorial. बुझिएला? पूजा, is it clear? Then come to fundamental principle of counting. Fundam Fundamental principle of counting are of two types. Fundamental principle of multiplication The second one is fundamental principle of addition. Now, if J1 and J2, sorry, if an event occurs in m different ways, if an event occurs in m different ways, and for each way of occurrence, of the event, another event occurs in n different ways, if an event occurs in n different ways, and for each way of occurrence of the event, another event occurs in n different ways, then the number of ways both the events can occur equals to m into n. If an event occurs in m different ways, and for each way of occurrence of the first event, another event occurs in n different ways, then the number of ways both the events can occur is equal to m into n. Suppose this is event E1. The event E1 occurs in m different ways. This is suppose first way of occurrence of the event E1. This is second way of occurrence of the event E1. This is third way of occurrence of the event 1. And this is nth way of occurrence of the event 1. For the first way of occurrence of the event E1, another event E2 is there, which can occur in n different ways. For the second way of occurrence, event E2 can occur in n different ways. For third way of occurrence, event E2 can occur in n ways. And for nth way of occurrence, event E2 can occur in n different ways. So the number of ways both the events E1 and E2 can occur is equal to n plus n plus n plus n. How many times? M times is equal to m into n. In another way also we can define it. If J1 and J2 are two dependent if J1 and J2 are two dependent subjobs of job J such that J1 and J2 can be completed in m and n different ways, then the job J can be completed in m into n different ways. Here the main job is J. J1 and J2 are two dependent subjobs. That means when J1, J2 both are complete, then the main job J is complete. J1 can be completed in m different ways. J2 can be completed in n different ways. So main job J can be completed in m into n different ways. Is it clear? ଯିବା କ୍ୱେଶ୍ଚିନ୍ କରିବା ୟା ପରେ। There are 10 boys and 8 girls in a class. The class teacher has to select a boy and a girl to represent the class in how many different ways? The selection can be made. There are 10 boys and 8 girls in a class. The class teacher has to select a boy and a girl to represent the class in how many different ways the selection can be made. Okay. There are 10 boys and 8 girls in the class. So for class representative, a boy will be selected and a girl will be selected. A boy out of 10 boys can be selected in how many different ways? A boy out of 10 boys can be selected in 10 different ways. And a girl out of 8 girls can be selected in 8 ways. Thus, the total number of ways a boy and a girl can be selected in 10 into 8, 80 ways. I hope it is clear to you. Is it clear? Let's move forward to the next question. How many three-digit numbers with distinct digits that means repetition of digits is not allowed. How many three-digit numbers with distinct digits can be made using the digits 1, 2, 3, 4? How many three-digit numbers with distinct digits can be made using the digits 1, 2, 3, 4 if the repetition of digits is not allowed? Come to the solution. A three-digit number contains three places such as units place, tens place, and hundreds place. We have to fill up all these three places using the digits 1, 2, 3, 4 in such a way that no digit is repeated. Okay. Since four digits are available, the units place can be filled up in how many different ways? Four different ways. Once the units place is filled up, the digit taken in the units place cannot be taken in the tens place. So the number of possibilities for the tens place is three. So the tens place can be filled up in three different ways, and the last place, that is hundreds place, can be filled up in two different ways. So the total number of ways are total number of three-digit numbers is equal to 2 into 3 into 4, which is equal to 24. Is it clear? বুঝিপারল? Okay. Next question. Just a minute. Next question. How many three-digit even numbers can be made by using the digits 1, 2, 3, 4, 5 if repetition of digits is not allowed? How many three-digit even numbers can be made by using the digits 1, 2, 3, 4, 5 if repetition of digits is not allowed? Try to answer this question. Twenty-four. Okay, let me check. I think the answer is correct. A three-digit number contains three places: units place, tens place, and hundreds place. Since the number will be an even number, so the unit place digit should be an even digit. So units place can be filled up either by 2 or by 4. So this can be filled up in two different ways. Once the units place is filled up, the digit taken in the units place cannot be taken in the tens place. So the tens place can be filled up in four different ways, and the hundreds place can be filled up in three different ways. So the total number of ways is equal to 2 into 3 into 4, which is equal to 24. Okay. Next question. How many five-digit numbers divisible by 3 can be made by using the digits 0, 1, 2, 3, 4, 5. If repetition of digits is not allowed. Subhankar Jena 600. No, Subhankar, 600 is not the correct answer. No, 360 is not the correct answer. Okay, let me solve it. The digits available are 0, 1, 2, 3, 4, 5, and we have to form a 5-digit number which is divisible by 3. A number is divisible by 3 if the sum of the digits is divisible by 3. So we can take the number as 1, 2, 3, 4, 5. Okay. Number of 5-digit numbers taking 1, 2, 3, 4, 5 equals to, this is first place, second place, third place, fourth place, and fifth place. The first place can be filled up in 5 different ways, second place 4 different ways because repetition is not allowed. Third place can be filled up in 3 different ways. This is 2 different ways, this is 1 way. So total number of ways is equal to 120. Okay, again, zero, 1, 2, 4, 5. Sum is 12, which is divisible by 3. Since 0 is there, 0 can't be taken in the extreme left position. So the extreme left position can be filled up in 4 ways. Then the next position in 4 ways, 3, 2, 1. So total number of ways is equal to 4 into 4 into 3 into 2 into 1 is equal to 96. Thus, total number of 5-digit numbers with such restriction is equal to 120 plus 96 is equal to 216. Is it clear? तीन तो गोटे थर प्लेस कले ना गोटे थर एटी 1 2 3 4 5 नहीं कले से कहूँ नंबर फॉर्म करवा डिविजिबल बाय 3 एटी कौन कले 3 नेले सेकंड केस 3 की ड्रॉप कर देले and repetition is not allowed. ଯାହାକୁ ନବା ସେ ପାଞ୍ଚଟା ଯାକ ୟୁଜ୍ ହଉଥିବା ଦରକାର। ବୁଝିହେଲା ପୂଜା? ହୁଁ 4 5 ଫାଷ୍ଟ ସିଲେକ୍ସନ ଆସୁଛି, ସେକେଣ୍ଡ ସିଲେକ୍ସନ ଆସୁଛି, କିଛି ଅସୁବିଧା ନାହିଁ। ତମେ ଏମିତି ପାଞ୍ଚଟା ନେବା ଦରକାର ଯାହାର ଡିଜିଟ୍ ସମ୍ 3ରେ ଡିଭିଜିବୁଲ ହେବା ଦରକାର, କାରଣ ଡିଜିଟ୍ ସମ୍ 3ରେ ଡିଭିଜିବୁଲ ହେଲେ ଯୋଉ ନମ୍ବରଟା ଆମେ ଫର୍ମ କରିବା ସେଟା 3ରେ ଡିଭିଜିବୁଲ ହବ। ବୁଝିହେଲା? Next question. How many 7-digit numbers 'can be formed by using the digits zero, 1, 2 up to 7, 8, 9, whose sum of digits is even? How many 7-digit numbers can be found by using the digits 0, 1 to up to 9 such that sum of the digits is even? What is the answer? Hmm. Sudhanshu, you are correct. First place, second, third, fourth, fifth, sixth, and seventh. Here repetition is allowed. So seventh position can be filled up in 9 different ways because zero cannot be taken at the extreme left position. Okay. So this place can be filled up in 10 ways, 10 ways, 10 ways, 10 ways, and 10 ways. So already six positions are filled up. Now we have to find out the digit sum in these six positions. If the digit sum is even, an even digit will be taken in the units place. If the digit sum is odd, then an odd digit should be taken in the first place. So number of odd digits is equal to 5 and number of even digits is equal to 5. In any case, the first place can be filled up in 5 different ways. So the total number of ways is equal to 9 into 5, that is 45 into 10 to the power 5. This is the answer. 45 into 10 to the power 5. ବୁଝିହେଲାନି ହଉ ଆମେ କଣ କରିବା ପ୍ରଥମରେ ଆଗେ ଲେଫ୍ଟ ଆଡୁ ଫିଲ୍ଅପ୍ କରିବା ଲେଫ୍ଟରେ ତ ଜିରୋ ନେଇ ହବନି ତେଣୁ ଲେଫ୍ଟ ପୋଜିସନ 9 ୱାଇଜରେ ତାପରେ ଆଉ ପାଞ୍ଚଟା ପ୍ଲେସ୍ ଆମେ ମନ ଇଚ୍ଛା ଫିଲ୍ଅପ୍ କରିଦେବା କାରଣ ରିପିଟେସନ ଆଲାଉ ଅଛି 10 ୱାଇଜରେ ହେଇଯିବ ଏ 6 ପୋଜିସନ ପର୍ଯ୍ୟନ୍ତ ଆମେ ଫିଲ୍ଅପ୍ କରିସାରିଲା ପରେ ଦେଖିବା ଯାହା ଯାହା ଡିଜିଟ୍ ନେଇଛେ ସେମାନଙ୍କର ସମ୍ କଣ ଆସୁଛି ହେଲା କି 10 ଏଥିପାଇଁ ନେଲେ ଯେ 10 ଡିଜିଟ୍ସ ଆର୍ ଦେୟାର ତେଣୁ ଏଇ ପର୍ଯ୍ୟନ୍ତ 6 ପୋଜିସନ ପର୍ଯ୍ୟନ୍ତ ଯଦି ସମ୍ ଇଭିନ୍ ଅଛି ତାହେଲେ ଫାର୍ଷ୍ଟ ପ୍ଲେସରେ ଗୋଟେ ଇଭିନ୍ ଡିଜିଟ୍ ନେବା ସିକ୍ସ ପୋଜିସନ ପର୍ଯ୍ୟନ୍ତ ଯଦି ସମ୍ ଅଡ୍ ଅଛି ତାହେଲେ ଫାର୍ଷ୍ଟ ପୋଜିସନ ଗୋଟେ ଅଡ୍ ଡିଜିଟ୍ ନେବା ଅଡ୍ ଡିଜିଟ୍ 5 ଅଛି ଇଭିନ୍ ଡିଜିଟ୍ 5 ଅଛି ତେଣୁ ଏଇ ଫାର୍ଷ୍ଟ ପୋଜିସନ ସବୁବେଳେ 5 ଡିଫରେଣ୍ଟ ୱେଜରେ ଫିଲ୍ଅପ୍ ହବ ବୁଝିହେଲା ପୂଜା ପୂଜା ଇଜ ଇଟ୍ କ୍ଲିୟର ଇନ୍ ଆଉ ୱାନ୍ ଏଇଟା ତ ଯଦି ଏପର୍ଯ୍ୟନ୍ତ ଏଇ ପର୍ଯ୍ୟନ୍ତ ଆମେ ଫିଲ୍ଅପ୍ କରିସାରିଲା ପରେ ଦେଖିବା ଯେ ଡିଜିଟ୍ ସମ୍ କଣ ଅଛି ଯଦି ଡିଜିଟ୍ ସମ୍ ଇଭିନ୍ ଅଛି ତାହେଲେ ଗୋଟେ ଇଭିନ୍ ଡିଜିଟ୍ ନେବା ଯଦି ଡିଜିଟ୍ ସମ୍ ଅଡ୍ ଅଛି ଗୋଟେ ଅଡ୍ ଡିଜିଟ୍ ନେବା ତାହେଲେ ଇଏ ପ୍ଲେସ୍ ସବୁବେଳେ 5 ଡିଫରେଣ୍ଟ ୱେଜରେ ଫିଲ୍ଅପ୍ ହବ ତାହେଲେ 9 into 5 into 10 to the power 5 then come to fundamental principle of addition. If J if J1 and J2 are two independent if J1 and J2 are two independent subjobs of job J such that J1 and J2 can be completed in M and N different ways, then the job J can be completed in M plus N different ways. If J1 and J2 are two independent subjobs of job J, such that J1 and J2 can be completed in M and N different ways, then the job J can be completed in M plus N different ways. ଏଇଟା job J ଅଛି the ଦିଟା part ନବା J1 and J2. These are independent subjobs. Independent subjob ମାନେ ୟାଦର କୌଣସି ଗୋଟେ complete ହେଲେ main job complete ହେଇଯିବ. First subjob ଟା M wise ରେ complete ହେଉଛି, second subjob ଟା N wise ରେ complete ହେଉଛି. J1 complete ହେଲେ main job complete, J2 complete ହେଲେ main job complete. ତାହେଲେ total number of ways the job J can be completed is M plus N. ଯିବା question କରିବା. Write down a question. There are 10 boys and 8 girls in a class. The class teacher has to select either a boy or a girl to represent the class. In how many different ways? In how many different ways the selection can be made? There are 10 boys and 8 girls in a class. The class teacher has to select either a boy or a girl to represent the class. In how many different ways the selection can be made? Okay, this is the question. 18, yes, 18 is the correct answer because one boy out of 10 boys can be selected in 10 ways, and one girl out of 8 girls can be selected in 8 ways. So a boy can represent the class, a girl also can represent the class. So the total number of ways is equal to 10 plus 8 is 18. 18 is the correct answer. Okay. Pooja, is it clear to you? Yes, 18. Okay, your first session is over, guys. Second session will start at 9:15. We'll continue permutation. Good morning. Good morning, Shubhankar. ଆମେ ଏବେ ଯିବା ନେକ୍ସଟ କ୍ୱେଶ୍ଚିନ୍ କରିବା ପୁଣି ଫଣ୍ଡାମେଣ୍ଟାଲ ପ୍ରିନ୍ସିପଲ ଅଫ ଆଡିସନ ଉପରେ ଗୋଟେ କ୍ୱେଶ୍ଚିନ୍ କରିଥିଲେ। ବିଜୟ ସାର୍ ପ୍ରଣାମ। Next question. There are 20 delegates in a conference. If every individual has sex with the other, then find the total number of handshakes. There are 20 delegates in a conference. If every individual handshakes with the other, then find the total number of handshakes. Can anybody answer? Not 20 factorial. Parameshwar, it is not 20 factorial. Suppose 20 delegates means 20 persons. Suppose person 1, person 2, person 3, up to person 20. Okay. अच्छा, person 1 handshake करिवे, केतटा handshake करिवे? He will handshake with other persons in 19 ways. अच्छा, person 2 handshake करिवे केतटा? ना already person 1 person 2 सहित handshake कर देंगे। person 2 other person सहित केते ways रे करिवे? 18 ways. person 3 17 ways. person 19 1 way. Already person 20 सहित समस्त handshake कर देइतवे। So total number of handshakes is equal to 1 plus 2 plus 3 plus up to 19. This is equal to 19 into 20 divided by 2. Sum of first n natural numbers is equal to n into n plus 1 by 2. This is equal to 190. Okay, then next question. Find the number of diagonals of a hexagon. Find the number of diagonals of a hexagon. Hmm. 9. Okay. A hexagon has 6 faces and 6 sides: A, B, C, D, E, F. The join of any two vertices is either a side or a diagonal. The join of any two vertices is either a side or a diagonal. If you join A with B, that will give you a side. If you join with A with C, that will give you a diagonal. So the total number of ways the vertices can be joined with each other is equal to total number of sides plus total number of diagonals. Total number of ways the vertices can be joined with each other is equal to total number of sides plus total number of diagonals. Okay. So vertex A can be joined with the other vertices in 5 ways. Vertex B can be joined with other vertices in 4 ways. Vertex C can be joined in 3 ways. D in 1 way, D in 2 ways, and E in 1 way. The total number of ways the vertices can be joined with each other is equal to 5 plus 4 plus 3 plus 2 plus 1 is equal to 15. Thus 15 is equal to number of sides plus number of diagonals. So 15, this implies 15 is equal to number of sides is 6 plus number of diagonals. This implies number of diagonals is equal to 15 minus 6 is equal to 9. Next question. Is it clear? Did you understand? Write in the chat box. Okay. Find the number of diagonals of a polygon of n sides. Find the number of diagonals of a polygon of n sides. Shubhankar, what is the answer to this question? And the number of diagonals. Yes, n square minus 3n by 2 is the correct answer. Let me explain it. The number of diagonals is n square minus 3n by 2. The polygon of n sides has n vertices. Okay. So vertex 1, vertex 2 up to vertex n. So the vertices can be joined with each other in the number of OH. Vertices can be joined with each other equals n minus 1 plus n minus 2 plus up to 3 plus 2 plus 1. That is 1, 2, 3 up to n minus 1. N minus 1 into n divided by 2. N square minus n by 2. The vertices can be joined with each other is equal to total number of sides plus total number of diagonals. Thus, number of sides plus number of diagonals equals n square minus n by 2. This number of sides is n plus number of diagonals equals to n square minus n by 2. This implies number of diagonals equals to n square minus n by 2 minus of n square minus 3n by 2. Next question. If the number of diagonals of a polygon is 44, then find the number of sides of the polygon. The number of diagonals of a polygon is 44, then find the number of sides of the polygon. Shivankar, what is the answer, Pooja? Yes, 11 is the Priyadarshini, you are correct. Let the number of sides be n. Yes, Shubhankar, 11 is the correct answer. Let the number of sides be n. So n square number of diagonals is equal to n square minus 3n by 2. N square minus 3n by 2 is equal to 44. This implies n square minus 3n is equal to 88. This implies n into n minus 3 is equal to 88. This implies n is equal to 11. Next question. How many different triangles can be formed by joining the vertices of a decagon? How many different triangles can be formed by joining the vertices of a decagon? Shubhankar, what is the answer? 120. Join of any three vertices is a triangle. The total number of ways three vertices can be selected out of 10 vertices is equal to 10C3, 10 factorial upon 3 factorial into 7 factorial, 8, 9, 10 by 6. So 4 into 3 into 10 is equal to 120 is the correct answer. Next question. There are 20.5 points. In a plane of which 5 points are collinear, except these 5 points, no 3 points are collinear. How many different straight lines can be formed by joining these points? There are 25 points in a plane of which 5 points are collinear. Except these 5 points, no 3 points are collinear. How many different straight lines can be formed by joining these points? What is the answer? Shubhankar, Pooja, Priyadarshini. 191. Okay. Let me check the answer. How many points are there? 25 points. Out of which 5 points are collinear. Suppose point 1, point 2. Collinear means the points lie in a straight line. 3, 4, 5. Except these 5 points, no 3 points are collinear. The total number of points is 25. Join of any 2 points determines a straight lines. So total number of straight lines is equal to total number of OH the vertices can be joined with each other which can be done in 24 plus 23 plus 22 plus up to 3 plus 2 plus 1 ways is equal to 24 into 25 by 2. This is equal to 300. Okay. Since these 5 points are collinear, join of any two will give you a straight line, but not the different straight line. So these 5 points should give you 4 plus 3 plus 2, 1 straight lines, but they are actually giving only one straight line. 5 collinear points can produce only one straight line, but they should produce form, they should form 4 plus 3 plus 2 plus 1, that is equal to 10 straight lines. Quickly note it down. I'll go to the next page. The total number of straight lines is equal to 300 minus 10 equals to 290. This is the answer. Okay. Next question. Yes, 5 points give one straight line only, but they should give 10 straight lines. So total number of straight lines so formed is 300 minus 10, that is 290. Then come to permutation. No, 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 291. Oh, sorry, 291. Sorry. It is 291. Plus 1. It is 291. Subhankar, you are correct. It is 291. Then come to permutation. Each of the different arrangements each of the different arrangements, those can be made out of number of objects taken all or some at a time is called a permutation. Each of the different arrangements, those can be made out of a number of objects taken all or some at a time is called a permutation. For example, suppose we have three objects A, B, C. What are the different arrangements? By taking two at a time, the different arrangements, one of the arrangement will be AB, then BA, BC, CB, AC, and CA. These are all the possible arrangements taking two at a time. Now you can say AB is an arrangement, BA is an arrangement. Now you can say AB is a permutation, BA is a permutation, BC is a permutation, CB is a permutation. So there are six permutations. So synonym for permutation is arrangement. Permutation means arrangement. Permutation means arrangement. So note it down. In permutation, order of the objects is taken into consideration. That means if order changes, then permutation will be different permutation. Because in the arrangements AB and BA, order is reversed. So if the order is changed, then the permutation will be different permutation. Okay. Write down a theorem. The number of permutations just a minute, guys. The number of permutations of n distinct objects taken R at a time the number of permutations of n distinct objects taken R at a time is denoted by NPR or PNR, which is defined by NPR is equal to n factorial upon n minus r factorial. The number of permutations of n distinct objects taken R at a time is denoted by NPR or PNR, which is defined by NPR is equal to n factorial upon n minus r factorial. Right? NPR is equal to n factorial divided by n minus r factorial. Come to the proof. The number of permutation of n objects taken R at a time is equal to the number of which n boys can be seated in a row having R places. The number of permutations of n distinct objects taken R at a time is equal to number of which n boys can be seated in a row having R places Okay, let the n boys be boy 1, boy 2, boy 3, like boy n. R places are there. This is suppose first place. This is second place. This is third place. And this is earth place. The first place can be occupied by any one of the n boys. So the possibilities for first place is n. Once the first place is filled up, that means the boy who is seated in the first place can't be seated in the second place. The number of options available for the second place is n minus 1. Similarly, the number of ways the third place can be filled up in n minus 2, and the number of ways the earth place can be filled up is in n minus r plus 1. So the total number of ways these r places can be filled up, thus the total number of ways these r places can be filled up is equal to n minus r plus 1 into n minus r plus 2 up to n minus 2 into n minus 1 into n. To convert it into factorial notation, we have to multiply the product from 1 to n minus r. This will be 1 into 2 into 3 up to n minus r. Then the next term will be n minus r plus 1 into n minus r plus 2 up to n minus 1 into n divided by 1 into 2 into 3 into n minus r. Now the numerator is a continued product from 1 to n. It will be n factorial, and denominator is 1 to n minus r. So n factorial upon the denominator is a continued product from 1 to n minus r. It will be n minus r factorial. Thus NPR is equal to n factorial upon n minus r factorial. I hope it is clear to you. Is it clear? Pooja, Shubhankar, Priyadarshini, full screen. ଶୁଭଙ୍କର କଣ ଫୁଲ୍ ସ୍କ୍ରିନ୍ ଲେଖିଛ କଣ? ଦେଖାଯାଉନି କ୍ଲିୟରଲି କି? ଶୁଭଙ୍କର, oh, now is it okay? Shubhankar? Okay. Hmm. So NPR is equal to n factorial upon n minus r factorial. So 5p2 is equal to 5 factorial. If n is equal to 5 and r is equal to 2, it will be 5 factorial upon 5 minus 2 factorial. This is equal to 5 factorial upon 3 factorial, which is equal to 4 into 5. 4 into 5 is equal to 20. Got it? So now we'll discuss some questions on permutation. Question number 1. How many three-digit numbers with different digits can be formed by using the digits 1, 2, 3, 4, 5. Different digits means repetition of digits is not allowed. Okay. Already we have solved this type of question on fundamental principle of multiplication. Now we'll solve it by using permutation formula. Okay. How many digits are available? 5 digits are available. Write down the number of three-digit numbers with different digits using 1, 2, 3, 4, 5 is equal to the number of permutations of 5 different objects taken 3 at a time is equal to 5p3. 5p3 is equal to 5 factorial upon 5 minus 3 factorial, which is equal to 5 factorial upon 2 factorial. This is equal to 3 into 4 into 5 is equal to 60. I hope it is clear to you. Just a minute, guys. We've done some important points on permutation. Some important points in permutation. Point one, the number of permutations n distinct objects taken R at a time in which a particular object appears at a particular place is n minus 1 p r minus 1. The number of permutations of n distinct objects taken R at a time in which a particular object appears at a particular place is n minus 1 p r minus 1. Okay, come to the explanation. So n objects are there. Let the n objects be A1, A2, A3, an minus 1, n. Okay, these n objects will be arranged in R places in which a particular object appears at a particular place. This is suppose the first place, this is second place, this is third place, and this is earth place. A particular object always appears at a particular place. Let that particular object be A2. Suppose A2 always appears at the third place. Now place A2 at the third place. After placing A2 at the third place, how many places are available? R minus 1. How many objects are available? N minus 1. And the permutation of these N minus 1 objects taken R minus 1 at a time will be N minus 1 P R minus 1. Shubhankar, is it clear? Pooja, Priyadarshini, Vishwajit, is it clear? Okay. Okay. I'll give an example on this, where to use this formula. Okay. A question on the previous point. How many three-digit numbers with distinct digits can be formed by using the digits 0, 1, 2, 3, 4. Okay. How many three-digit numbers with distinct digits can be formed by using the digits 0, 1, 2, 3, 4 if repetition is not allowed? Or distinct digits means repetition is not allowed. So how many objects are there? 5 objects. They will be arranged in 3 places because we have to form a 3-digit number. So answer should be 5p3. But you know, if 0 is taken at the extreme left position, then the number will be 2-digit number. So the answer is 533, but we have to calculate how many numbers are there in which 0 is at the extreme left position. If 0 is taken at the extreme left position, so we have to arrange two other places, that is 10th place and 100th place, by using 1, 2, 3, 4, and that can be done in 4p2 ways. Okay. So answer to this question is 5p3 minus 4p2. Particular object taken at a particular place. Shubhankar, I hope it is clear to you. Okay. No, sir. Priyadarshini, ବୁଝିପାରିଲନି? ଆମକୁ କହିଥିଲା 3-digit number form କରିବା using the digit 0, 1, 2, 3, 4. ଆମର ଆନ୍ସର ହବା କଥା 5p3. କିନ୍ତୁ 5p3 କରିସାରିଲା ପରେ ଆମେ ଦେଖିଲେ ଯେ since 0 is there, 0 can't be taken at the extreme left position. କାରଣ 0, 1, 2 ଏଇଟା କ'ଣ 3-digit number ହବ କି 2-digit number? ତାହେଲେ 0 କୁ ଏକ୍ସଟ୍ରିମ୍ ପୋଜିସନରେ ନେଇକି ଏକ୍ସଟ୍ରିମ୍ ଲେଫ୍ଟ ପୋଜିସନରେ ନେଇକି କେତେଟା ନମ୍ବର ପସିବୁଲ ସେଟା ଆମେ କାଲକୁଲେଟ କରିବା and those numbers should be subtracted from 5p3. ତାହେଲେ 0 କୁ ନେଇଗଲେ ଏକ୍ସଟ୍ରିମ୍ ଲେଫ୍ଟ ପୋଜିସନ ପର୍ଟିକୁଲାର ଅବଜେକ୍ଟ ପର୍ଟିକୁଲାର ପ୍ଲେସ ରହିଗଲା ଆଉ ପ୍ଲେସ ରହିଲା କେତେ 2 ଅବଜେକ୍ଟ କେତେ ରହିଲା 4 ତାଙ୍କର ପରମୁଟେସନ ହବ କେତେ 4p2 ତାହେଲେ 0 କୁ ଏକ୍ସଟ୍ରିମ୍ ଲେଫ୍ଟ ପୋଜିସନରେ ନେଇକି କେତେଟା 3-digit number possible 4p2 3-digit numbers are possible. The total number of such numbers is equal to 5p3 minus 4p2. Priyadarshini, is it clear? Okay. Then next note point or important point. The number of ways n objects of one kind and different and n minus 1, the number of ways n objects of one kind and different and n minus 1 objects of another kind and different can be arranged in a row such that no two objects of same kind come together is n factorial into n minus 1 factorial. The number of ways n objects of one kind and different and n minus 1 objects of another kind and different can be arranged in a row such that no two objects of same kind come together is n factorial into n minus 1 factorial. Let the first kind objects be A1, A2, A3 up to An minus 1, An, and second kind objects be B1, B2, B3 up to Bn minus 1. We have to arrange these 2n minus 1 objects in a row in such a way that no two objects of same kind come together. Since first kind objects is one more than the second kind objects, the arrangement starts with the first kind object. So first number of first kind objects is n. So they will take n places. Suppose the cross places, n cross places are there, which will be occupied by the first kind objects. So these n places can be occupied by these n objects in npn ways. Npn is equal to n factorial. Okay. Since no two first kind and no two second kind objects come together, so the intermediate positions, that is the tick positions. Okay. The intermediate, since n objects are there, so there will be n minus 1 intermediate positions. These n minus 1 intermediate positions will be occupied by the n minus 1 second kind objects. That can be done in n minus 1 p n minus 1 ways. N minus 1 p n minus 1, which is equal to n minus 1 factorial. Okay. And the by fundamental principle of multiplication, this can be done in n factorial into n minus 1 factorial ways. Is it clear, Subhankar, Priyadarshini? Yes, Subhasmita. Okay, let us come to discuss a question on this concept. In how many different ways? Write down a question. In how many different ways? 4 boys and 3 girls can be seated in a row such that neither two boys nor two girls are together. In how many different ways? Four boys and three girls can be seated in a row such that neither two boys nor two girls are together. Shubhankar, what is the answer? Four boys, they will take four places. Four boys can be arranged in four places in 4 ways, that is 4 factorial. Since neither two boys nor two girls are together, so girls will occupy the intermediate positions. So there are three intermediate positions and three girls. So three places, three objects that can be filled up in 3p3 ways, which is equal to 3 factorial ways. Since the total work will be completed only when the boys and as well as girls are seated. So it is fundamental principle of multiplication. This can be done in 4 factorial into 3 factorial. This is 24 into 6. This is equal to 144 ways. Is it clear? Shubhankar? Shubhankar, you are from which higher secondary school? DD, Keonjhar, Dharnidhar. So guys, today's session is over. So rest of the things we will discuss in your next schedule. I think it is on Monday. Okay. Okay. विजय सर प्रणाम. एबे क्लास एंड कर दवा सर.